Consider a fun example that resembles the kind of questions that the US antitrust authorities often have to consider. So suppose that there is a market with two firms, and let's assume that is the simple linear symmetric case in which the aggregate demand function is this linear one, and remember Q denotes the total amount produced, and the firms have marginal cost equals to mu for both firms. This simple case that we have been looking at to really get intuition for the oligopoly. Now, this is the initial state of the market, and then the question is, what happens to efficiency, to deadweight loss, if the firms merge? What happens to deadweight loss? This is very important for antitrust authorities because in more realistic and more complicated examples, in order to decide whether or not they approve a merger of two firms, they have to decide, they have to measure whether this is good or bad for consumers, and they're going to look at things like what is the change in social surplus, the change in efficiency, the change in consumer surplus. So let's play with this case. So we're going to do here what happens before, and here what happens after. And remember, this is going to be the case of when they act together as a monopolist. This is going to be the case in which they act together as an oligopoly. Not together, sorry, separately, competing in parallel as oligopolistic firms. Now, we know what happens in this case in oligopoly, that each firm ends up producing a quantity P max minus mu divided by 3m, that the price in the market ends up being 1/3 P max plus 2/3 mu. We solved that before. And that the deadweight loss ends up being P max minus mu squared over 9m. I'm just copying from our notes what we knew happened before. Now let's think about what happens in the monopoly case. The problem of the firms that when they merge together is to decide how much to produce together in total, given that they face this demand function. And since the marginal cost per unit is constant, we don't have to worry about how much is produced by the old factory of firm 1 or the old technology of firm 2. The constant cost per unit produced is mu is the same. So it's going to maximize over Q greater or equal than 0, Q times P max minus MQ minus mu Q. Total revenue minus total cost. We know that this is going to look at the marginal revenue of that equals marginal cost, and that this is going to be equal to P max minus 2MQ equals mu, which implies that the quantity in the monopoly case is going to be equal to P max minus mu divided by 2m. So we already get the first insight when we compare the total quantity of the oligopoly is going to be this, which is going to be 2/3 of this quantity divided by m, is going to be greater than the quantity of the monopoly. So notice that the quantity of the oligopoly is greater than the quantity of the monopolies. We can also easily compute the price by substituting back in the inverse demand function to be, in the case of the monopolist, so price of the monopolist is going to be equal to 1/2 of P max plus 1/2 of mu. So not surprisingly, given that the quantity of the monopolist is less, we have that the price of the monopolist is greater than the price at the oligopoly case. And finally, we can compute the deadweight loss using this of the monopoly case using the same tricks as we have used before. This is going to be equal to 1/2 the price of the monopolist minus the price at the competitive equilibrium allocation or the efficient allocation times the quantity of the monopolist minus the quantity that is optimal, or the quantity generated by the equivalent outcome if the firm has behaved competitively. And if you do the algebra, you get that this is 1 divided by 8m P max minus mu squared. Okay. So what do we have? We have that if you move from oligopoly to monopoly, you increase the deadweight loss. Surprisingly, not by as much as you would expect in the case of two firms, an oligopoly with two firms versus a monopolist, but it goes up nevertheless. So it's not good for efficiency.